Alright guys, so my goal is to eventually create the PowerPoint slides and then do my instructional videos based off of those slides and to have that for every unit. That's just not the case at the moment, and so I'm going to try to do the instructional one off of the notes and give you just tips on how I would teach it, how I would explain it, and what we can do with that. So this first section, if you'll notice in the entire module for chemistry, matter, and energy, that there's very little classwork assignments and there's really not a whole lot of homework assignments because a lot of this is just facts, it's just information. And so there's not really skills to be practiced. And in the units where there's more of an emphasis on just facts and regurgitation of those facts, you're generally going to have less handouts. And also, I do that twofold. One, because by the time they're taking high school chemistry, students should be able to study straight from notes. But second, this is one of those things I don't think is as important of a unit. And so I want to push the pace a little bit by not having you pause to do handouts and classwork and homework and that kind of thing. So we start with just basic, what is chemistry? And take this and tweak it whatever fits your science background. What are you most comfortable with? How can you explain how chemistry intersects with real life? How can you explain how they're going to need this information going forward and just kind of set the stage? Moving down, I've got this little demo activity that I do with simply, carbonated water or soda water and tap water. And so you only need, you need water, soda water, and then some type of copper chloride solution, copper 2 chloride solution. I'm trying to remember what concentration I use. You can just kind of play around with it. I don't think it has to be very strong. But you're just trying to demonstrate for the students kind of how the scientific method works. That instead of making them memorize a set of steps, gather information, make your hypothesis, test, experiment, make a conclusion. Instead of making them memorize things specifically, what I do is trying to show them in this demo that the scientific method is actually how we intuitively go about approaching life in general. And so I give them this demo without even saying, hey, we're talking about the scientific method. And then I basically guide them through the scientific method as we go along. And it ends up really kind of bringing it home that, no, this is just good thinking skills. And then after we do the demo, we go into the steps of the scientific method. This is a big thing here to me, that it must be testable to be valid. A lot of people try to make hypotheses about things that you just can't test, and it doesn't really work that well. Experiment conclusion. This is a common place that students get confused or have bad information, and a lot of teachers have bad information here too. I oftentimes hear people tell me that a law is just a stronger form of a theory. That's not correct. Theories and laws actually do two different things. A theory is trying to explain how something happens, where a law simply describes what is happening. We know the law of gravity, we know what it does, but we don't know the how and why it does. We don't have a unified theory of gravity that is accepted across the board, because we don't really know exactly how gravity works, other than it's related to masses and distances. And then kind of talk about scientific research, pure and applied. This is pretty cut and dry. Then we get kind of into the beginning of chemistry, describing matter. What is matter? Is anything that takes up space? I really try to ask this question for them. What's not matter? I want them to know that the air in the room is matter. And a lot of times they're like, but it doesn't have mass. At which point in time, it's always good to have a balloon on hand. If you put an empty balloon on a scale and weigh it, and then take that balloon and blow it up, and then put it on the scale, it will show that it is heavier. Or even better yet, you can have a student do it, since, they'll be a little less skeptical of the results if a student does it. But you can show them that air has mass by simply blowing up a balloon and weighing it, and it will be heavier. And you're showing that it takes up space. And then we talk about chemical and physical properties. Main distinction here is chemical properties change something's identity. It's no longer itself. That when I burn paper, it's no longer paper. It's now ash and whatever vapors were given off, whatever gases were given off as it burned. Same thing with physical and chemical changes. I do have a lab that goes through this and explains this. I can do a separate video on the lab if y'all would like me to do that. Here it's simple how we divide matter into pure substances, which are elements, and compounds. Compounds being a combination of elements, like water is 2 hydrogens and an oxygen. It's a compound. Salt, NaCl. It's a combination of 2 elements. And then mixtures, heterogeneous and homogeneous. You get the giggles over homo. Still do to this day. But you can even use those giggles to explain it. That homo means same. That someone who is homosexual, like someone of the same sex. Someone who is heterosexual, like people of the opposite sex, are different. And so I use that to show them the prefix of same and different. That homogeneous are things which are same throughout. An example I use in these notes is a Coke. You take a sample from the top of a Coke can, the middle of a Coke can, the bottom of a Coke can. It's all going to be the same. And then for heterogeneous, my go-to example is a Dairy Queen Blizzard. Feel free to use your flavor of choice. I usually use Snickers. I have Oreo written here, but Snickers is usually the one I use. Because you can have a bite of Blizzard that's like all big chunks of candy, one that's like half candy, half ice cream, and then one that's all ice cream. Every bite's a little bit different. It's not going to be the same all the way through. And we kind of run through some examples there. Talk about elements, where the names come from, that some of the weird ones come from old Latin names. Then we talk about compounds in more detail, mixtures in more detail. Then we talk about ways of separating mixtures. These are all physical ways of separating things. Then there's a lab on separating salt and sand. That's a good classic lab to do here, to show them that you can separate something that looks homogeneous but really isn't, and you can pull it apart that way. And then the last thing in this unit is energy. Just trying to get them once again into the idea of radiant, kinetic, and potential energy. Kinetic versus potential, the whole idea of a roller coaster. You go up the hill, and that is potential energy. You're putting potential energy into the system. And so at the top of the hill, you have no motion, but you have lots of stored up energy. You start going down the hill, and all that potential energy is converted into kinetic energy, into speed. And when you get to the bottom, you're at the bottom. You have no more potential left, and so there's no way to go faster, but you've got all that energy in the kinetic. And so that can kind of explain there. I don't spend a whole lot of time on energy, just because that's more of a physics thing, but it's usually in this chapter, and so we do it. I talk a little bit about this, but I don't spend a whole lot of time here just because I know I'm going to come back and hit it when we do heat and reactions second semester. All right, then law of conservation of energy. This is a good place to, and we'll work on this, getting a nuclear reactions kind of introduction to the idea of nuclear reactions. E equals mc squared, that energy equals mass times the speed of light squared. And that's what's happening in a nuclear reaction, whether fusion or fission. And it's kind of this, standards want us to at least introduce the idea of a nuclear reaction. And that they know what fusion is, they know what fission is, and they're familiar with this equation. So it's a good place to kind of throw that in there. And so that's the first module. And so for me, I pretty much just go through this. I've got the demo, I've got a lab or two, and then which is kind of getting them used to how I do labs and how I wanted things to be done. And then it's pretty much a regurgitation of facts. This is a really straightforward unit. It's kind of a good unit for you to get familiar with them and for them to get familiar with you.